Hello, my dear students. Welcome to your very own faculty driven institute, Resultant. Hope you guys are fine. So, guys, be quick and join the session fast. Come on, guys, be quick, quick, quick. Let's be quick. Okay, be quick, guys, and join the session fast. And so, now we will be starting the session. Okay, I guess I'm audible and visible. So, the first thing is welcome again. And after a long time, I'm here live with you guys. And if you are new to our channel and if you haven't subscribed it, kindly subscribe it, like it, and share it with maximum of your friends. Apart from that, if you don't know about me, you can go through my profile. And guys, we are having a new faculty launch for civil engineering, IIT Delhi, gate toppers, 7 years of teaching experience. So this will be revealed to you this coming Sunday. Okay, apart from that, guys, we have launched a rank up courses, practice courses for GATE 2025, numerical for your mechanical branches. 320 hours of live classes will be there, study notes, PYQs, quizzes, formula notes. Apart from that, excuse me, for civil engineering, we have launched the crash course Theory plus Numericals, 320 plus hours of live classes, study notes. Right now, the offer price is going on is 7,999 and the classes will start from 16th of September. Okay, so why to wait, guys? Be quick and register yourself. For more queries, you can call on the numbers which is being provided to you here, or you can mail us support at the rate resultant.in. Apart from that, you can call on the number 79913104116. Okay, apart from that, guys, we will be happy that if you join our resultant team, we'll be having live test recorded classes, study notes, PYQs, doubt sessions, and test series. And now we will be starting the questions. So I guess everybody is ready now. Shall we start? Okay, so now we'll start the session without any delay. It has been a long time, like I told you, that me taking live classes. So now your wait is over. Now I'll try that at least I should come often as much as possible. And now let's start, guys. Fine. Okay. So one questions, many concepts. This is the first question for you. And actually, these pattern of questions they have not asked in your GATE examinations. And if you talk about environmental engineering, there will be definitely, if it comes for 12 marks, generally it will be coming for 10 to 12 marks. There will be one question which will be out of the box. That means you might have not heard that formula, you might have not studied that concept, so that will be a different thing. So that is the reason I have come up with those questions which will definitely help you out. Okay. The questions, multiple things will be there. So a part of it can also be asked if they want to create it as 1 marks question, or two question. If like they want to create it as an MCQ question, they can ask you two, three things on that. Okay. Hello, Aaron. Okay, now we'll start with the session. In a water treatment plant, raw water is passed through a filter bed of uniform sand at a velocity of 5 meter per hour. So what they have given to you? They have given to you the velocity as 5 meter per hour. Now the filter bed, generally we can make it of anthracite, activated charcoal, but we are using sand grains whose diameter is given to you how much? 0.4 mm. Shape factor is, we take it as generally denoted by 5. It is given to you 0.85. Now generally they haven't asked questions related to shape factor much in your environment. So shape factor is given 0.85. Specific gravity is given to you 2.65, and they have told that the depth of the filter bed, you can denote it by L or D. I denoted by D, capital D, is given to you 0.67 meters. Porosity is given to you zero point 0.4, and it is asking you determine the head loss through the bed. Come on, guys. Density of water, they told you to take it 998. If nothing would have been given, we would have taken it as 1000 kg per cubic meter. But since it has told you to take 998, we will take that only. And dynamic viscosity means mu is given to you 10 raised to power minus 3 kg per meter second. Come on, now solve it. Determine the head loss, guys. Come on. Actually, if I know, as far as I know, whether you remember the formula of head loss, there's one Rose equation and all which is given. Guys, do you remember? Anybody of you who remember the formula? I'll paste the question on the other slide also so that we don't have to turn the slides often and check it out. Okay. Nobody remembers. Fine. Nobody remembers it only. So the formula I am writing it again. The question I have written it again. The head loss formula. I told you this question before. Means I told you the formula beforehand, not the question. 1.067 v square by d. V is what? Your velocity. Phi is shape factor. G n to the power 4. N is your porosity. CD divided by d. This is the formula of head loss. So till now, if you don't know the formula of head loss, this is the formula of head loss. Now you will say that, ma'am, they haven't asked such type of questions ever. So let me tell you, this year irrigation, there was one question which they never ever asked. It means till the time from when this gate exam has started, not even related to that they have asked. But this year, both in forenoon and afternoon session, they have asked it. And every year I used to solve that question. I used to make the students solve that question with the hope that this question will be coming, but never. So that's why now I'm making you solve this question. If it will come from next year, everybody will teach for 2026. But what to those students who have been studying it for gate 25? They have lost it. So that's why you need to get prepared for it. Okay. So this is the formula of head loss. Now check it out what is given to you in the question. They have given to us the velocity. How much? 5 meter per hour. Now meter per hour they have given to you. First you will convert it into what unit? You'll convert it into which unit, guys? Meter per hour is given to you. So here only I'll do it what? I'll convert it into meter per second. Okay. 1 hour is equal to 60 minutes. 1 minute is equal to 60 seconds. So 5 divided by 3600. 1.3888888 it is coming. So 1. Excuse me, meter per second. This will be your velocity. We'll substitute this. Now what they have told you, D. So D is the depth of the filter bed. In the question they have given you, I have mentioned it here, that is 0.67 meter. So this is 0.67 meter. Shape factor they have given to you as 0.85. Acceleration due to gravity, nothing is mentioned. We will take it as 9.81 meter per second square. Porosity they have mentioned to you 0.4. Okay. And the grain dia they have given to you 0.4 mm, which I'll take it as 0.4 into 10 raised to power minus 3. Now the whole thing will be dependent on coefficient of drag. Tell me how will you calculate it? The whole thing will be dependent on coefficient of drag. Tell me how will you calculate it? Come on. How will you calculate coefficient of drag? That is the main thing which you have to discuss in this question. Come on. See, if you remember, we have three types of flow. Now, here in this question, they have not mentioned whether it is a laminar flow, transitional flow, turbulent flow. They haven't mentioned. So, if these question comes for 2 marks, first you have to identify whether the flow is the laminar flow, transitional flow, or turbulent flow. This you have to identify. Correct? Now, if I talk about it, how can I know, ma'am, that whether it is a laminar flow, transitional flow, or turbulent flow? For that, you have to calculate the Reynolds number. Okay, and how can I calculate Reynolds number? Reynolds number is given by the formula rho Vd by mu. Come on, density is given to you 998 kg per cubic meter. Viscosity is given to you, dynamic viscosity 10 raised to power minus 3 kg per meter second. How much is V given to you? How much is V given to you, guys? V. How much is V given to you? Nobody? See, either you can use rho Vd by mu or you can use Vd by nu. But here in this question, I told you maximum people will use rho Vd by mu or they will use Vd by nu. But you know what? Since in this question, shape factor is given, you have to take shape factor into account. Before that, never they used to give shape factor. So in Reynolds number, we used to do rho Vd by mu or Vd by nu. But since in this question they have given shape factor into account, you will not write like this. And I'm writing it and I'm cancelling it and I'll not erase it, so that when I'll share this PPT with you in the form of PDF, you make sure that you also don't do this mistake. Am I clear till here? No, we won't go. First, we have to calculate the C for calculating CD. First, I have to calculate Reynolds number. And for that time, I'll check it out whether it is a laminar flow. If it would be laminar flow, I would do 24 by RE. Okay. If it would have been turbulent flow, I would have used different. That time 1.8 we directly take. If it is transitional, 24 by RE plus 3 upon RE plus half plus 0.34, we use that. Okay. So we have to first check it out with the help of Reynolds number. So how we will get it? So we will get it as V phi D by nu. Got it? By this we will calculate it. Now solve it, guys. V phi D. Come on, come on. V phi D. Now this you can do it, guys. That is very simple. Velocity I've already calculated. How much? 1.389 into 10 raised to power minus 3. Shape factor they gave you is 0.85. Dia they gave you as 0.4 mm. Nu, you know, dynamic viscosity by density. That is how much? 10 raised to power minus 3 divided by 998. How much it will come? 1.002 into 10 raised to power minus 6 meters square per second. 1.002 into 10 raised to power minus 6. So firstly, okay, first all this, then I'll tell you one more thing. Okay. 1 point. Now doing it in your scientific calculator it is easy, but doing it in your virtual calculator will be a pain. Huh? 2 minus 6. You guys can also solve it. What happened, Sanket? 0.471. 0.471 is your Reynolds number coming. And this Reynolds number is less than what? It is less than 0.5. Since the Reynolds number here is less than, since Reynolds number here is less than 0.5, flow is laminar flow. Clear? So now since flow is laminar flow, from here the coefficient of drag will come 24 by RE. So definitely it becomes a 2 marks question. How much is Reynolds number you got? 0.471. Come on, solve it guys quickly. 24, 50.92. Now you have to substitute it here. 50.92, that's it. Now first remembering this is a task, but if you want, you can practice 2-3 questions, automatically you'll remember this formula. Come on, quickly solve it. Or you'll want me only to solve it because I am the one who will be giving the paper, right? How much it is coming? 0.131. Huh? If it is, see, in foreign author books they take it different, and in Indian author books they take it different. So either it will be 0.5 or either it is less than 1. In both cases, the Reynolds number, you will, some books they take 0.5, some books they take 1. Okay? Clear, Arun? So how much this is coming, guys? Solve it. This is 4. I have written here. I made a, this is 4. So my answer will be different. Wait, I don't know why I have written it square here. 1.067 into 1.389, 10 raised to power minus 3.67. 50.92. So this will come out to be 0.822 meters. 822 meters. So this will be your answer. This will be your answer. Okay. So what you got in this question? What you got in this question, guys? Actually, this question covered many of your concepts. What are the concepts? First, you should know the Rose equation for solving it. So this is the Rose equation which you need to remember. First thing. Okay. Secondly, in this question, they have not given, if they would have given you coefficient of drag, the question would have become easier. Now, let us suppose if they wouldn't have given you coefficient of drag, but if they would have given you the Reynolds number, then also the question would have become easier. But they have given nothing out of it. Okay. After this, coefficient of drag is not given to you. So for that, first you calculated Reynolds number. Generally, you remember these two Reynolds number formula, but since your shape factor is given, you have to take that into account. Okay. After that, the next is you should know that for laminar flow, coefficient of drag is given by this one. So how much? One, two, three. Three things is being covered in this question. Is it clear? Is it clear? Okay. So now we will be coming up with your last question for today's. Now this question will also be taking into account your multiple concepts. First, we'll read it, understand it. Obviously, they will not give you n number of things which is asked in this question, but I took this question so that many of your concepts will get clear. Okay, a rapid sand filter is to be provided in a water treatment plant to process the water for a town. The population is given to you as how much? 2,75,000. Water demand they have given to you per person per day is 200 liters per capita per day. The rate of filtration is 15 meter cube per meter square per hour. So technically they have given to you as 15 meter per hour. Now it is saying allow 5% of filter water to store to meet the backwash requirement. So here they have told you the volume of the percentage of water technically required for backwashing. Okay, then they have told you the backwashing duration is 30 minutes. Now first part we'll go. Determine the number of filters required allowing one as standby. Very, very, very important. Unless and until they mention you in the question to compute the number of filters including standby, don't add plus one because obviously one filters we keep it for standby. If it is not telling you, don't take it into account. Since it is telling you here, we have to take it into account. Okay, so now first we will calculate the number of filters required. Okay, how can we calculate? First we need to know how much is the discharge. Okay, if I calculate the discharge, the velocity is known, I'll calculate the area. Okay, so let's start it from here. So first one person requires 200 liters. So the whole population will require how much amount of water? So volume of water to be filtered. Now how much? 2,75,000 into 200 liters per capita per day. Come on, solve it, guys. Quickly solve it. See, one thing more in this question, if it would have been your ESC conventional question, that time you would have provided a note that we are assuming it that we are designing it for maximum daily demand. Nowhere in the question, if you check it out, they have mentioned that we have to design it for maximum daily demand. So actually in the gate, they'll mention it like design, discharge and all. And suppose if they're telling you to design it for maximum daily demand, then you would have multiplied by 1.8. But since here they haven't told you about the maximum daily demand, we will not be designing it for that. Okay, fine. Now solve it. 200 liters per capita per day. So from here, 275,000 into 200. That is 55 into 10 raised to power 6 liters per day. Okay, that is 55 mld. Okay, so technically this is the, not the volume, because this is the discharge. I haven't multiplied with the, I won't have multiply here the time, I will multiply later. Requirement of water to be filtered. Now actually we require 5% of water for backwashing is required for backwashing as well. Okay, so total quantity of water to be filtered will be 55 mld plus 5% of 55 mld. So that will be 55 into 1.05. How much it will come? 57.75 mld. This much quantity of water has to be filtered. Right now I'm not converting it into meter cube per second and all. As and when required in the question, I'll convert it. So total quantity of water to be filtered is 57.75 mld. But ma'am, we want to know the number of filters. Now this much quantity of water I require in how many hours? 23.5. How ma'am? Generally, I would have required it in 24 hours, but 24 hours the filter is not running for filtration. You say, how come you know? Check it out. In the question, they have mentioned that the backwashing period is 30 minutes. So, the time for which the filter is in operation will be how much? 24-hour minus 30 minutes. That is 30 by 60. So, that is 23.5 hours. Till here, anybody is having any doubts? I'm waiting for your comments. Any doubts? Okay. So how much filtered water is required per hour? Filtered water required per hour. How much it is required? We require 57.75. But this we cannot have it in per day. This will be required in 23.5 hours. So million liter per hour. So divide by 23.5. So this will be 2.457 million liters per hour. This much amount of filtered water is required. See, you have to do it very quickly, fast. But right now, since I'm explaining, I'm going on each and every point in detail. This much amount of filtered water is required. Okay. Now, filtration rate they have given to you as how much? Check it out, 15 meter per hour. See, they have given to you filtration rate or rate of filtration 15 meter per hour. So area will be how much? Discharge by velocity. Discharge is 2.457 into 10 raised to power 6 liters per hour, and velocity is discharged by rate of filtration. This will be your area. Velocity is 15 meter per hour. You know 1 liter is equal to 10 raised to power minus 3 meter cube. So 10 raised to power minus 3. From here, hours and hours will get cancelled out. You will meter will go, you will get the answer in meter square. How much? 163.829. So I'll take it as 163.83. This is the, I'm getting the total area of filtration. But ma'am, in the question it is asking you the number of filters required. So they have given the size of one filter in a unit. Total area if I know, and if I know the size of one filter, I can get how many number of filters are there. Okay. The number of filter units, total filter area upon area of one filter unit. So 163.83 divided by one filter unit is how much? 10 meter into 4 meter. 10 meter into 4 meter. So 163.83 divided by 40. This will come out to be 4.095. So how many filters you will take? 4.095. So we'll take it as 4. Okay. And since it has told you to take one as standby, Total filter units will be 4 plus 1. That is 5. So this is the answer for first part of the question. Am I clear? Am I clear with the first part of the question? Everybody? Okay. So this was an easy one. Not much required. Only thing in this new concept was, which you remember, which you forget, is that you have to divide it by 23.5 because they have mentioned the backwashing period. Now let's go for the second question. Compute the upflow velocity and the head loss to expand the filter bed to 0.66 from its undisturbed depth of 0.6 meter. That means the initial depth is 0.6 meter. You are expanding it. The expanded depth of it is how much? 0.66 meter. Okay. The porosity currently is 0.50 meter. Okay, so it is asking you first that you have to compute the upflow velocity. Now guys, how will you do it? Come on. Upflow velocity means the backwash velocity. So first, if you don't know why, because rate of filtration takes place from top to bottom. What takes place in up direction? The backwash velocity. So it is asking you that you should know the backwash velocity. How can you calculate? Anybody has any idea? How can I calculate? If you know, based on this concept, this formula, they have asked a question. Expanded porosity is given by VB by VS 0.22. But in this question, you have to calculate backwash velocity also, and expanded porosity is also not given. Even the settling velocity is also not given. So in this question, nothing is given to you. So you have to calculate settling velocity, expanded porosity, and backwash velocity, all the things. Come on, guys. Now let's solve it. Let's solve it. I'll add 2, 3 more slides. Wait a second. Okay. Now you know they have told you assume the flow to be transitional. This is one thing. You remember one formula d square by 18 u gs minus 1 into g, that remember. But here it has not told you it is laminar. This is transitional in nature. So how will you calculate? I told you according to Stokes equation 4 by 3 gs minus 1 gd by cd. Specific gravity is mentioned to you in the question. Check it out. How much? 2.5. And drag coefficient 5.02. If nothing is mentioned, you will take acceleration due to gravity 9.1. Dia of the particle also they have mentioned it out. The average particle size is 0.6 mm. Mm you will convert it into meters. So 0.6 into 10 raised to power minus 3. So this you have to calculate from here. First you will get the settling velocity. So I'm dealing this bigger quotient. Of course they can ask you one or two parts of it. So you should know about it. Okay, from here we'll get the settling velocity in meters per second. 4, 1.5. This will come 0.0484 meters per second. This will be your settling velocity. Okay, so you got the settling velocity from this formula, but ma'am, expanded porosity also I don't know. Remember one more, hydraulic head loss which takes place through unexpanded bed, that will be there through the expanded bed. Both will be equal because the buoyant weight of the particles is same. So d 1 minus n is equal to d 1 minus d e expanded depth porosity. Okay, so depth they have mentioned initially is 0.6. Porosity, I'll check it out. Then this was 0.66 if I remember. So what is the porosity? Let me check it out quickly. The porosity is 0.50. The porosity of the bed was initially 0.50 and head loss to expand the bed to 0.66 meters from its 0.6 meter. Porosity was 0.50. Correct. So porosity was 0.50. Depth is 0.6 only. Come on. Solve it. From here you will get the expanded porosity. Quick, quick, quick. So this will be 0.6 into 0.50 divided by 0.66. 1 minus. So this will come 0.545454. So that is 0.545. Now everything is sorted. You know it. You know expanded one is 0.5454. Settling velocity you calculated is as 0.0484. Backwash velocity. We'll get it from here. First of all, you need to remove this 0.22. So multiply in the power by 1 upon 0.22. So 1 upon 0.22 into, this will come from here 3.078 into 10 raised to power minus 3 meters per second, or you can say 0.3078 centimeters per second. So whatever unit they ask you, this is the backflow velocity, but instead of that, for confusing you, they will write it as upflow velocity. Okay, so have we calculated everything? Compute the upflow velocity, done. Head loss to expand. Head loss, you can use the formula, either this one, head loss d1 minus n, this one you can use it, okay, or you can use the one which is de1. Both will give you the same. Okay, so this is zero point 0.6, 1 minus 0.5, specific gravity is 2.5 minus 1. Come on, if you, fine, I'll do it in both so that you can know that both will give you the same answer. 0.45 meter. Or if you use the other formula, expanded porosity, expanded depth, GS minus 1. So this is specific gravity, same, this was 0.66. 1 minus what is expanded porosity? 0.5454. Point 0.45 meter. So you use, I told you now, this head loss will remain same whether it is through the unexpanded bed or through the expanded bed. Reason, the buoyant weight of the particle is not changing. Clear? Madam, for calculating net quantity rate of filter, just a minute, I haven't seen your comment right now. Wait a second. मैडम तुम्हें पढ़ाना भी है. Some people will come here and they'll spread all these things. Madam, for calculating net quantity of filtered water, rate of filtration into area and duration. No, not correct. Reason is, see, there are two things which are there. You are confusing both of the things. One is your backwashing period and one is your the period which you give time for maturation. Both are the different things. Backwashing period, what you do is, in the backwashing period, you clean the filters. Whatever impurities are there, whatever the impurities which are trapped, you need to just do what? You need to free it. The impurities, while you do backwashing, if you don't have sufficient, you can say space available, or you don't have the sufficient velocity, you can go for air compressor also. Okay, so that the impurities will be set free, expansion of the filter bed will happen, the impurities will go through the trough, and from there they will go to the wash water gutter. Okay, that is the backwashing. When you talk about maturation, after you have done with the backwashing, right now that smart stay clear, which is responsible, this smart stay clear has to be formed. Some people call it a smooth stay clear also, different pronunciations. So this layer has to be formed so that whatever is microorganisms and organic matter are there, they are trapped. This is biological in nature. For biological process to happen, it takes time. Okay, so after backwashing, generally you give time for maturation purpose, so that whatever water is right now coming from the filter, that water, whatever coming from either raw water or either plain sedimentation water or coagulation aided sedimentation water, which you are passing it through the filter bed, right? What you will do is, you will not take it to the disinfection unit, right? Why, ma'am? Because since the filter is backwashed, right now the smart stay clear has been removed. So you are giving time for maturation. Maturation means you are giving time for the smart stay clear to be formed. Correct? And that will require time. So until and unless that is being mentioned to you, Shashi Kumar, you cannot take that into consideration. And it has been only once till now where they have given you separate times. If I remember, 15 minutes, there was one question in GATE previous years. 15 minutes time they have given for backwashing period, and 30 minutes time they have given for maturation time. Before that, never ever they talked about maturation. So until and unless it is given to you in the question, you will not take into account. Clear? Anybody else also has doubts, can ask to me. So guys, these were the two questions which I have discussed. In this questions, we have covered what are the things. This one, what is upflow velocity? This you should know, this formula of expanded porosity. Okay. Then the settling velocity by transitional flow, hydraulic head loss, all these. Correct? So these are the things which you should know. If other questions are simple, if you talk about filtration, other questions, if you remember these things, that's it. Provided you take care of the timing of the maturation and backwashing, right? In this question, as Sashi Kumar told, if they would have mentioned to you in the question about maturation and all, you would have to take that into consideration, but it was not mentioned here. Otherwise, let us suppose, like what you are saying, Shashi, if let us suppose in this question they have told 15 minutes for backwashing and 30 minutes for maturation, 45 minutes. So here I would have done 24 minus 45 by 16, and then I would have calculated filtered water required per hour. Got it? So in this way I would have done it. Clear? Anybody else is having any doubts? Anybody else? Fine. So these were the questions, guys, and if you want me to make video or any other topic, kindly do comment it in the comment section. You can join my Telegram group, Civil by Richa Gupta. Will be sharing this PDF with you on that. Okay. Apart from that, guys, we have launched the batches for 25, as you already know. Apart from that, we'll be having the target course 26. You'll be getting live plus recorded classes, study notes, PYQs, question banks, doubt sessions, and complete test series. And if you want, you can follow us on the Instagram, resultant.in, Facebook, or you can mail us if you have any queries, support at the rate resultant.in. And if you have any more queries, you can call us on the number 7991310416. You can also download Resultant Civil, Resultant Mechanical app from the Play Store. Okay, so that's all for today, guys. Take care of yourself. Bye bye, good night, and study hard. Thank you, everybody. Thank you so much.